Now the other kind of inequality that we're going to look at are the rational inequalities. This is where we have the numerator and denominator going on. And most of what we're going to do, it looks similar to what we were doing with polynomials, but there's kind of one extra step added in because of the numerator and the denominator. So let's kind of walk through the general steps. First off, we will go ahead and make sure that we have it as less than or greater than 0. We want everything on one side, and we want to make sure one side is 0. Now, there is this one step here that we sometimes see, and that is we want to make sure to combine everything into one rational expression, which basically that means get everything into one fraction, if necessary. Sometimes some terms can be kind of spread out, and so we have to combine into one fraction. Okay, once we've kind of consolidated everything together like this, the next step is to take both the numerator and the denominator and solve both of those set equal to 0. So that's going to be the whole solving step that we did in the last ones. Once we have that, we'll go ahead and put those on the number line. We'll choose our test values, and then we'll figure out which ones work and which ones don't work, and those are going to be the part that is our solution. So that's going to be the kind of the differences now, looking at both numerator and denominator. So let's look at this one here on part A. X minus 4 over x plus 3 greater than 0. So this is already together into one fraction, and one of the sides is already 0. So what I'm going to do here is I'm going to take the numerator equal to 0, and I'm going to take the denominator equal to 0. Okay, with the numerator, just the x minus 4 equal to 0, which just means we add over the 4, and we get x equals 4. Denominator, x plus 3 is equal to 0. We subtract over the 3. We'll get x is equal to negative 3. Okay, so those are two numbers, and we're going to put those numbers on the number line and choose some test numbers. Okay, so looks like on one side of negative 3 I can choose negative 4. In the middle there's a 0, and on the other side of 4 I can choose a 5. So let's set up our intervals here, negative infinity to negative 3, negative 3 to 4, and 4 to infinity. Okay, here's our test values. And now what are we going to be plugging these test values into? We're plugging it into x minus 4 divided by x plus 3, and we're checking for greater than 0. So let's see how that goes. If we plug in negative 4, it would look something like this, which turns into negative 8 divided by negative 1, which is just equal to positive 8. Since this is greater than 0, this one checks out as part of our solution. We plug in 0. It will look like negative 4 divided by 3. So now we're a negative number. Since that's negative, it's not greater than, it's less than, so that one doesn't work. If we plug a 5 in, looks like we're going to get positive 1 over 8. That is greater than 0, so that one checks out. So we have two different parts that check out as our solution. And we can put those together to make the full solution to this inequality. So parentheses in this case, we're going to keep with the parentheses since we're using just the greater than, not the greater than or equal to. Okay, so we have here the two intervals. negative infinity to negative 3, and 4 to infinity. Those two together make up the solution. Okay, now the one we're going to look at here has the greater than or equal to 0 situation. But just like last time, we're going to set the numerator equal to 0 and the denominator equal to 0, making sure that we have it all combined into one fraction and the other side is 0, which we do. So we'll have negative x plus 2 is equal to 0. Let's see, we subtract over the 2, negative x equals negative 2, which tells us that x is equal to 2. And then for the denominator, x minus 4 is equal to 0. So when we add over the 4, x is equal to 4. So two numbers to check on the number line here. We got our 2 and we got the 4. And we need to choose some test values. Test values I used here are 0, 3, and 5 on either side of those numbers. So here are the intervals that we're looking at from the number line. Okay, I'm using parentheses, but keep in mind that we'll double check if we need to do brackets or parentheses when we're done. Here are the test values that we have. And where are we going to plug these? It's going to be in for x with negative x plus 2 over x minus 4 greater than or equal to 0. So we're checking for greater than or equal to here. Okay, if we plug in 0 for x, 0 plus 2 divided by 0 minus 4, that's going to be a negative 1 over 2. So we see a negative, that one doesn't work. Negative 3 plus 2 divided by 3 minus 4. It's going to turn into negative 1 divided by negative 1 or positive 1. So positive, this one would work, greater than 0. Plugging in 5, negative 5 plus 2 divided by 5 minus 4. That's going to turn into negative 3. So another negative number, this one doesn't work. So we only have one interval here that is the solution. So I'm going to write that out here on the number line. And let's see what we need to use for brackets or parentheses. Now, it does say that we are using greater than or equal to. So usually that means we will be using brackets. So we're going to put a bracket for negative 2, like that. However, we would usually put a bracket with 4 in almost all other things that we would do. But this one's just a little bit particular because that 4 came from the denominator. Since the 4 comes from the denominator, we have to make sure that we cannot include this in our solution because that doesn't work to have a 0 denominator. So in this very specific situation, I'm actually going to put a parenthesis here with 4 because we can't include the 4, and if I put a bracket there, that would mean that it could also equal to the number 4. So we're actually going to have bracket 2, which is good, comma 4, close parenthesis, just because we had to use the denominator to get that 4. Any other time, if it was greater than or equal to, I would use the bracket instead.